Now in part A, we have to find the z value for the probability 0.9296, and it's given that z is greater than k. Now, first making the probability normal distribution graph over here. So once we make the graph and we know that the probability is greater than k, it means it's towards the right of k. So first we can make the central point, which is 0. Now, as the probability towards the right hand side is 0.9296, it means that the z value must lie towards the left of 0, as the probability towards the right is 0.9296. Now we already know that towards the left, it is the negative area, which means that the z value will be negative. Now we'll go to the point in the table where the probability is 0.9296 or closest to 0.9296. So over here we have 9251, 9265, 9279, 9292, and then we have 0.9306. So this 0.9292 is closest to 0.9296, and the z value, corresponding z value, is 1.4 and 1.47. So we can note 1.47 over here. Now if we add 4 to it, it will become 9296. So we have 4 over here with the corresponding z value, which is 3. So we can add 3 over here, and the z value or the k value will be 1.473. However, as we already figured out that this value will be negative, so the value of k will be negative 1.473. In part B, we have to find the probability of z greater than k, and the probability is given as 0.0298. And again, making the table first. So once we make the table, greater than k would mean the probability towards the right. So in this case, as it is towards the right and this probability is less than 0.5, so we know that k must lie somewhere over here, as this probability is given as 0.0298. Now in the table, all the values are above 0.5, but as the normal distribution graph is symmetrical, so we can subtract this probability from 1, and whatever probability we get, they both give the same k value, same z value. So first, subtracting 0.0298 from 1, we get 0.9702. Now the z value at 9702 and 0.0298 is the same. So we can find the z value at 0.9702. Again, looking at the table, so 0.9702 is, so the closest value to 9702 will be 0.9699, and the corresponding z value is 1.8 and 1.88. So we have 1.88 as a corresponding z value, and if we add 3, it will become 9702. So we have 3 over, here, which has the corresponding z value as 4. So the final answer will be 1.884. And as we know that this is towards the right or in the positive half, it means that the k value will be a positive, and the value was 1.884. So the value of k will be 1.884. In part C, we have to find the probability of z less than k, and that is given as 0.3552. Now, once again, making this normal distribution graph, the probability towards the left, as it is less than k, is 0.3552. It means that this z value or the k value must lie in the negative region, as this probability is 0.3552. Now again, as this is less than 0.5 and the normal distribution table does not give us probabilities less than 0.5, so we'll subtract it from 1, and this will give us the probability 0.6488, which represents this region. So we can find the z value with the corresponding probability, which is 0.6448. So going back to the table again, 0.644, and trying to look for 0.6448. So we have 0.6443 over here, and the corresponding z value is 0.37. So we can first note down 0.37. And if we add 5 to it, we'll get 0.6448. Now, as we do not have a 5 over here, so we can just simply add 4 to make it 0.6447, which is closest to 0.6448. And the z value over here is 1. So the final answer will become 0.371. And as we already knew that this value will be negative, so the value of k will be a negative 0.371.